Okay, let's unpack this. I really want to start with a vibe check on the whole tech industry right now, because it feels like we're living in, a tale of two cities. It's the best of times, and it is very, very clearly the worst of times.
It really is a split reality, isn't it? A total paradox.
Right. I mean, on one hand, you open up any news feed, you scroll through LinkedIn, and it is just a bloodbath.
Oh, yeah.
You see all these headlines about the year of efficiency. Big tech is just shedding jobs, trimming the fat, shutting down all those experimental divisions.
The moonshots are over.
The moonshots are over. It feels shaky. It feels like the big party that, started in 2020 is officially done and the lights are coming on.
It feels like a contraction.
Yeah.
A massive correction.
Exactly. But then, and this is the part that kind of breaks my brain a little bit.
Mm-hmm.
You look at the hard data for one specific part of the industry.
Just one slice of it.
You look at the infrastructure layer, the cloud, and it is absolutely screaming for talent.
It's a vacuum.
It's like a vacuum cleaner trying to suck up every single available engineer on the planet.
It is the great market anomaly.
Mm-hmm.
While let's call it the front end of tech,
Mm-hmm.
the consumer apps, the metaverse experiments, the marketing teams,
Right.
while they're all tightening their belts, the engine room is running hotter than it ever has.
Mm-hmm.
The boiler room is it's understaffed.
I had to pull the numbers on this because honestly, I didn't believe the hype at first.
I don't blame you.
But industry observations are showing something like, 27,000 open roles in India alone?
Just in India.
Just in India. And then worldwide, we're looking at over 500,000 vacancies.
1 million.
It's an insane number.
And we really have to be clear about what those vacancies are. We are not talking about, data entry. We're not talking about low-level IT support. We're just asking people.
Have you tried turning it off and on again?
Exactly. That's not what this is.
No, these are high stakes careers. I was looking at the salary bands for AWS solutions architects just in the US, and they are sitting comfortably between, say, $150,000 and in some senior cases, pushing past $250,000.
Oh, easily. And that financial incentive is there because the supply-demand gap is it's massive. We're looking at a projected 60% gap between the number of cloud jobs and the number of qualified engineers by 2026.
60%. That's not a gap. That's a canyon.
It is. And it's because the skill set has fundamentally changed. The people who knew how to wire up a server room in, say, 2005, that skill set doesn't translate one-to-one to the cloud. It's a totally different language. It's a different way of thinking.
So that's our mission for this deep dive. We're going to try and bridge that canyon. We're going to take this buzzword, the cloud, AWS, and we're going to dismantle it. I want to look under the hood.
Okay.
I don't want the brochure version. I want the mechanics version.
Let's do it. Let's look at the machinery, the plumbing, and the traps, because there are definitely traps.
But before we get to the really complex architecture, the VPCs and the load balancers, we have to go back in time a little.
We do.
We need to understand the why. Because Amazon didn't start out trying to build a global supercomputer. They were selling, paperbacks and toaster ovens.
That's right. They were an online bookstore.
Yeah.
But they had this massive internal problem. They were just growing so fast that their own IT teams couldn't keep up.
Right.
Every single time they wanted to launch a new feature like customer reviews or recommendations, they had to wait weeks for the hardware team to go buy servers, plug them in, configure the whole network, cool a room.
It was just bureaucratic deadlock. They were basically choking on their own growth.
Exactly. So around the early 2000s, they made a really radical decision. They decided to treat computing power not like hardware that you own, but like a utility.
Like electricity or water.
Precisely.
I love this analogy because it really clicks for people. I mean, think about your house. When you walk into your living room and you flip that light switch, you don't care how the electricity got there.
You don't manage the coal supply.
Yeah.
You don't go and inspect the turbines. You definitely don't own the power lines.
You just pay for what you use. If you leave the light on for an hour, you pay for an hour. If you turn it off, the bill stops.
And Amazon just said, why can't servers work like that? Before 2006, they didn't. If you wanted to launch a startup, you had to go buy the power plant.
You had to buy the physical servers, rent the air-conditioned room, hire a security guard to watch the door. It was all capital expenditure.
You had to spend, $50,000 before you even signed up your first customer?
And Amazon flipped it. They turned it into OPEX, operating expenditure.
Exactly. You rent the server by the hour. Or now you can even rent it by the second.
It sounds perfect. It sounds like the total democratization of tech. 2 people in a garage can now have the same computing power as, Netflix or NASA.
Mm-hmm.
But, and there is always a but, on this show.
There's always a but.
This utility model introduced a whole new kind of danger. Because if I leave the lights on in my house when I go on vacation for a week, my bill goes up, what, $20?
Maybe less. It's a negligible amount.
But if I leave a high-performance GPU-accelerated EC2 server running in the cloud because I forgot to click terminate...
Oh, you won't lose $20. You could lose your entire runway.
Yeah.
We call it bill shock. I've seen it happen to people.
Give me a horror story. I need to feel the pain on this.
Okay, here's a classic scenario. A startup founder, brilliant guy, decides he wants to train a machine learning model. So he spins up what we call a P3 instance.
Okay.
These are monster machines. They're packed with NVIDIA GPUs designed for really heavy lifting. And they cost dollars per hour to run.
So not cheap.
Not cheap at all. So he runs his script on a Friday afternoon. It's supposed to take maybe 3 hours. He thinks, okay, I'll just check it on Monday. Goes away for the weekend. Maybe goes camping. No phone signal.
I can see where this is going.
He comes back Monday morning. The script had failed 5 minutes in, but the server kept running.
Oh, no.
For 72 hours. He logged into a bill that was nearly $3,000 for nothing, for just idle silence.
That is terrifying. $3,000 for digital air.
And in the old world, the friction protected you. You couldn't accidentally buy a $10,000 server.
Yeah.
You had to sign purchase orders, wait for shipping, unbox the thing. It took weeks.
Right.
In the cloud, you can bankrupt yourself with a single click if you don't know what you're doing.
And that right there.
Yeah.
That's why the architects are getting paid $250,000. They aren't just builders, they're risk managers.
They are the guardians of the credit card. They know how to use the pickaxe without hitting their own foot.
So let's paint a picture of that old world a bit more vividly. We're calling this the Eaten Alive arc because I think people who entered tech in, say, the last 5 years, the cloud native generation, they have no idea what racking and stacking actually meant.
They have absolutely no clue. I started my career in that world.
Yeah.
Let me tell you, it was not glamorous.
I bet.
You'd spend days in these freezing cold server rooms. We called them data centers, but they were basically meat lockers for computers.
Because of the cooling, right? Computers hate heat.
Exactly. And the noise. It's just deafening. You've got thousands of fans spinning at 10,000 RPM. You're shouting to be heard. And you're physically hauling these heavy metal boxes, these servers, and screwing them into racks.
Wow.
You're cutting your hands on the metal chassis. You're untangling just miles of Ethernet cables that look like spaghetti.
It sounds so physical. It sounds miserable.
It was. And the inefficiency was the real killer. We call it the era of zombie servers.
Explain that. What's a zombie server?
Okay, so imagine you're a retailer. You have Black Friday coming up. You know your traffic is going to spike by 500% for, 3 days?
The big rush.
In the old world, you had to buy enough physical servers to handle that peak. If you didn't, your site crashed and you lost millions of dollars.
So you buy the iron, you rack it, you survive Black Friday.
And then Saturday comes, traffic drops right back to normal. But you still own those servers. You can't return them to Dell or HP. So for the next 362 days of the year, they just sit there.
Doing nothing.
Running, eating electricity, taking up floor space, doing absolutely nothing.
Zombies.
Industry statistics used to say that in on-premise data centers, something like 30 to 40% of servers were comatose, just wasting money.
And the cloud just completely flipped this on its head.
Totally. In the cloud, you spin up 500 servers for Black Friday. On Saturday morning, you terminate them. You stop paying. The capacity is elastic.
That word elastic, it's right in the name of the most popular service, EC2, Elastic Compute Cloud.
It is the defining characteristic. But again, this brings us right back to the skill gap. Because elasticity doesn't just happen by magic. You have to build it. You have to architect for it.
Right. And AWS it's massive. It currently commands about, 33% of the global market. That is bigger than Microsoft Azure and Google Cloud combined. But that dominance, it comes with complexity. When you log into the AWS console for the first time, honestly, it looks like the cockpit of a 747, but none of the buttons are labeled in English.
That's a great description. There are over 200 distinct services. You've got EC2, S3, RDS, Lambda, Fargate, Kinesis, Glue, Redshift.
It's just a word salad. It's totally overwhelming.
It is. And most people freeze. They think, I have to memorize all of this. You don't. You really, really don't. Out of those 200 services, maybe 20 are the core. The rest are just niche tools for very specific problems.
Okay, so we're going to focus on the core, the Lego blocks. But before we even touch the blocks, we need to understand the game board, the global map. Because AWS isn't just a website, it's a physical infrastructure that spans the entire planet.
This is the global infrastructure concept. It's all about regions and availability zones.
I feel like people use those terms interchangeably all the time, and they really shouldn't.
No, the distinction is absolutely critical. A region is a geographic area, Northern Virginia, Dublin, Tokyo, Sydney. These are separate markets.
Okay.
If you store data in the Tokyo region, it stays in Tokyo. It doesn't magically float over to Virginia.
And this is super important for laws, right? Like GDPR.
Huge. Data sovereignty.
Yeah.
If you have banking customers in Germany, German law might say that data cannot leave German soil. So you must select the Frankfurt region. If you pick Northern Virginia, you might actually be breaking the law.
Okay, so that's a region. But inside the region, you have availability zones, or AZs.
Right. An AZ is the physical data center, or more accurately, a cluster of them. But here's the critical engineering detail. AZs within a single region are physically separated by miles.
1 mile. Why not just put them next door to each other? Or I don't know, why not put them in different states?
It's a balancing act. We call it the blast radius.
The blast radius.
If a flood happens, it might take out one suburb. If a fire breaks out, it might burn down one industrial park. By separating the AZs by, say, 10 to 60 miles, you ensure that a disaster hitting AZA probably won't hit AZB.
But they're not too far apart.
Exactly. And this is where the physics comes in. They had to be close enough that the latency, the time it takes for data to travel between them, is under a few milliseconds.
Because if they were 500 miles apart, the actual speed of light would slow down your application.
You got it. Light is fast, but it's not infinite. And in computing, a few milliseconds is an eternity. If your database is trying to write data to 2 places at once and they're 500 miles apart, your app's going to feel sluggish.
Wow.
So AWS has to thread this needle far enough apart to be safe from disasters, but close enough to cheat the speed of light.
That is a fascinating constraint. It's literal geography dictating digital performance.
It is. And understanding that is what separates a junior dev from a senior architect. A junior dev puts everything in one building. A senior architect spreads it across 3 AZs because they know that eventually power will fail.
Everything fails all the time.
Yeah.
That's the Amazon motto, right?
Yeah, it's the famous quote from the CTO, Werner Vogels. You have to build, assuming things are going to break.
So that's the landscape. The hardware is gone, replaced by this massive global grid that we rent by the second. Now, I want to get into the machinery, the actual levers and dials. We've broken this down into the 4 pillars of AWS operations.
Right. Security, compute, storage, and databases.
Let's start with pillar 1, security, or as I like to call it, the bouncer.
The bouncer is a great analogy. In AWS, this is all handled by IAM identity and access management.
And from what I gather, IAM is not a friendly bouncer. This isn't the guy who lets you in because you slipped him a 20.
No. IAM is the strictest bouncer you have ever met in your life. The core philosophy is default deny.
Default deny. Explain that.
When you create a new user account for a developer on your team, let's call him Dave by default. Dave can't do anything. He can't see a server. He can't read a single file. He can't even list the names of your storage buckets.
So he's in the club, but he's blindfolded and handcuffed.
Exactly. He is standing in a pitch black room until you explicitly write a permission policy that says Dave can take off the blindfold. And then you write another one that says Dave can untie his hands.
That seems excessive. Why make it so hard?
It has to be. In a traditional corporate office, if you hire someone, they can probably walk into the kitchen, into the meeting rooms, maybe even peek into an unlocked office. In the cloud, that kind of openness is a massive vulnerability.
Right.
If a hacker gets Dave's password and Dave has access to everything, your company is dead.
So IAM allows for really granular control.
Extremely granular. You can write a policy that says Dave can read this specific file in this specific bucket, but only between 9 a.m. and 5 p.m., and only if he is logging in from the office IP address.
That is wild. But there's a trap here too, isn't there? The root user.
The root user. This is the single most dangerous entity in the cloud.
Who is the root user?
The root user is the account owner. When you first sign up for AWS, that email and password you use, that's root. It has unlimited power. It can delete the entire account. It can spin up those $1 million servers we talked about. It can delete all of your backups.
So using the root user for your daily work, like checking logs, spinning up a test server,
is like cutting vegetables with a lightsaber. One slip and you lose an arm, or in this case, your entire infrastructure.
I love that image.
It's true though. Best practice. You create that root account, you enable multi-factor authentication MFA, that's completely non-negotiable, and then you take those credentials, write them on a piece of paper, lock them in a physical safe, and you never touch them again unless it is an absolute emergency.
And you create an IAM user for yourself.
For daily tasks with fewer permissions. It's all about least privilege. That's the term.
Right. You only give people and yourself the exact amount of power they need to do their job. Nothing more.
Precisely. No more.
Okay, so we've got security lockdown. Let's move to pillar 2. Compute, the engine. This is EC2.
Elastic Compute Cloud. This is the bread and butter. This is the virtual server.
But it's not just one type of server, right? We talked about the Honda Civic versus the Ferrari earlier, but it gets way more specific than that.
Oh, it does. When you go to launch an EC2 instance, you are presented with a menu. And just like a fancy restaurant, if you don't know what you're ordering, you might end up with a bill you really didn't expect, or a server that just chokes on your code.
So let's look at the menu. We have these families of instances.
Right. You have your general purpose family. Those are the M series and T series. Think of these like the Honda Civic. They're reliable, they're balanced, they're good for a web server or maybe a development environment.
But wait, the T series has a quirk, doesn't it? The burst stable thing.
Oh, the T series. Yes. This is a classic trap for beginners. The T series is cheap.
Yeah.
Very cheap. But it runs on something called CPU credits.
Explain that like I'm 5.
Okay. Imagine you have a bucket of water. Every hour, AWS drips a little bit of water into your bucket. That water represents high-speed CPU power. When your website gets a visitor, you scoop some water out of the bucket to handle the request.
Okay, so as long as I have water in the bucket, I'm fast.
You're fast. But if your website goes viral and you suddenly have thousands of visitors, you start scooping water out way faster than it drips in.
And the bucket runs dry.
The bucket is empty. And when that happens, your server slows down to a crawl. It becomes almost unusable. It's throttled. I have seen sites go down because they used a T-Series instance for a huge launch event. They ran out of credits, and the server effectively died.
So don't use a Honda Civic to tow a boat.
Exactly. If you need raw power, you go to the Compute Optimized family, the C series. These are for high-performance processing, maybe video encoding or scientific modeling.
And then there's memory optimized.
To R series. These are for massive databases that need to hold a ton of data in RAM for really quick access. They're expensive, but they're absolute beasts.
And then there's this spot market. This just sounds like gambling.
It kind of is. AWS has all this spare capacity just sitting around. Maybe everyone's asleep in Virginia, so the servers are idle. AWS sells that spare capacity at a massive discount, sometimes 90% off.
90%? That's huge. What's the catch?
The catch is, if someone else is willing to pay full price for that server, AWS kicks you off. They give you a 2-minute warning, and then poof, your server is gone.
2 minutes.
2 minutes.
Yeah.
So you can't run a database on Spot. You can't run your main website on Spot. But if you're just processing data in the background and it can be interrupted,
it's a gold mine.
It's a gold mine for savings.
Fascinating. Now, within EC2, there's this concept of the Amazon machine image. It sounds super technical, but it's basically a save state for a computer array, right?
That is a great way to put it. Imagine you spend 3 days configuring a server. You install the operating system, all the security patches, the web server software, your own code.
Right.
In the old days, if you wanted a second server, you had to do all of that work again manually. With an AMI, you just take a snapshot of that perfect server. It freezes it as an image. Then you can say, AWS, give me 500 copies of this image, and boom. In minutes, you have 500 identical servers all running.
That is the power of scale. And you can also move that image around the world.
Right. You build it in Virginia, you copy the AMI to Tokyo, and you launch it there. Suddenly, you have a global presence. It completely decouples the software from the physical box.
All right, moving on to pillar 3, storage. The digital warehouse. We've got S3 and EBS, and I feel like people mix these two up constantly.
They do, and mixing them up is an architectural sin.
Let's clarify. EBS, Elastic Block Store.
EBS is block storage. The best analogy is the hard drive that's physically inside your laptop. It's fast, it's low latency, and it is attached to a specific computer. If your computer dies, the hard drive is still there, but you have to take it out and plug it into another computer to see the files.
So EBS is basically the brain of the EC2 instance. It's where the operating system lives.
Correct. But then you have S3 Simple Storage Service. This is object storage.
The locker in the hallway.
Perfect. S3 is not attached to any one computer. It lives on the internet. It is effectively infinite. You can store 1 file or 1 trillion files, photos, videos, backups, and you access it via a URL, just like a website.
What I find fascinating about S3 is the resilience stats. They always talk about 11 nines of durability.
Yes, 99.999999999%.
What does that actually mean in the real world, like for a normal person?
It means that if you store 10,000 files on S3, you might lose one of those files every 10 million years.
So basically never.
Basically never.
Yeah.
S3 automatically copies your data to at least 3 different availability zones. So even if 2 entire data centers burn to the ground at the same time, your cat photo is still safe.
That is seriously impressive. But let's talk about cost again, because S3 isn't just one price. There are tiers, right?
Oh, this is a huge cost trap here. You have standard S3, which is hot storage. It's ready instantly. But what if you have data you need to keep for legal reasons, like tax records from 7 years ago, but you never actually look at it?
You don't want to pay top dollar for that to just sit there.
No, you move it to Glacier.
Glacier, a very good name.
It's the deep freeze. It is dirt cheap. We're talking pennies on the dollar. But the catch is, if you need that file back, it might take 12 hours to retrieve it.
Wow.
It's like storing your files in a cave in Antarctica. It's safe, it's cheap, but it's really hard to get to.
And then there's versioning. We touched on this in the outline.
Versioning is a lifesaver. It's a time machine for your data.
How so?
Let's say you have a bucket full of critical documents, and an intern, or maybe a malicious script, accidentally deletes a file, or worse, overwrites it with a corrupted version.
Panic mode. Full panic mode.
If versioning is enabled on that bucket, S3 doesn't actually delete the old file. It just puts a little delete marker on top of it. You can just peel that marker back and restore the file as it was 5 minutes ago or 5 years ago.
So nothing is ever truly lost unless you really, really want it to be gone.
Exactly. And when you combine that with encryption using KMS, the key management service, you have a system that is incredibly durable and incredibly secure.
Okay, pillar 4, databases. And I love the analogy we have for this one. The chef.
Yes. So you could install a database manually on an EC2 server. You rent the server, you download MySQL or PostgreSQL, you install it, you configure the backups, you handle all the security patching.
That's cooking dinner yourself. You have to buy the groceries, chop the onions, do all the dishes.
And if the oven breaks at 3 a.m., you are the one who has to fix it.
Right.
RDS, the relational database service, hiring a chef. You just tell AWS, I want a MySQL database, and they provide it. They handle the underlying OS patching, they handle the backups, they handle the replication. You just eat the food. You just query the data.
But the chef costs more than just buying the groceries.
It does. Managed services like RDS definitely have a higher upfront cost on the bill. But, and this is the big yes but moment, you have to calculate the cost of your engineering time.
Right.
Do you want your best, most expensive engineers spending 10 hours a week patching database servers, or do you want them building new features for your customers?
It's a trade-off between cash and engineering hours.
And usually engineering hours are the most expensive resource any company has. So RDS often wins out. Plus, RDS has this killer feature called multi-AZ deployment.
Explain that.
You click one button, and AWS creates a perfect standby copy of your database in a different availability zone. If your main database fails, hardware crash, whatever it is, AWS automatically flips the switch to the standby.
And how long does that switch take?
Seconds. Often the application doesn't even notice it happened. If you tried to build that yourself manually, good luck. That is weeks and weeks of work and constant maintenance.
So we have our security, compute, storage, and database. Those are the Lego blocks. But now we have to talk about how they all connect. Part 3. Architecture and automation. This is where we get into the nervous system of the cloud, the VPC.
The virtual private cloud. This is where people get really lost.
To me, this just sounds like a gated community.
That is exactly what it is.
Yeah.
The public internet is a bad neighborhood. It's chaotic. It's dangerous. Everyone is constantly scanning everyone else's ports looking for a way in.
So you build a wall.
You build a VPC. It is your own isolated slice of the AWS cloud. Inside that VPC, you have total control over the networking, the IP addresses, everything.
And inside the gated community, you have different neighborhoods. These are the subnets.
Correct. You have public subnets, which are like the houses right near the main gate.
Yeah.
They have direct access to the internet through something called an internet gateway. This is where you put your load balancers or your public-facing web servers.
And then you have the private subnets.
The hidden safe rooms, the vault. This is where you put your database. This is where you put your core application logic. These subnets have no direct route to the outside world.
So how do they get software updates if they can't reach the internet?
That's where the NAT gateway comes in. It's like a secure courier. The private server asks the NAT gateway, hey, can you go get this update for me? The NAT gateway goes out, gets the file, and hands it back. But nobody from the outside can initiate a conversation with that private server.
So it's one-way traffic only. It's defense in depth.
It is. And you have layers of security guards. You have security groups, which act as a stateful firewall.
Stateful, what does that mean? They have a memory.
Yes. This is a really key concept. If a security group allows traffic in from a user, say, a request to view a web page, it remembers that interaction, and it automatically allows the response out. It's smart.
And then you have NACL's network access control lists.
The NACL is the stateless guard. It's like a badge reader at a door. It checks your ID on entry, and it checks your ID again on exit. It doesn't remember anything. Even if it just lets you in, it checks you again when you try to leave. It's a much stricter, cruder filter at the subnet level.
It sounds incredibly complex to wire all of this together. Connecting two VPCs isn't just, plugging in a cable.
No, it's called peering. And it is like building a private bridge between two private islands. You have to configure the route tables, which are essentially the GPS of the VPC, to tell the traffic exactly how to get from island A to island B. If you mess up that route table, the traffic goes into a black hole. It just vanishes.
Let's talk about keeping the system alive, because the whole promise of the cloud is scalability, the self-healing system.
This brings us to load balancers and auto-scaling, the absolute dynamic duo.
The load balancer is the traffic cop.
Right. You have thousands of users hitting your website. You don't want them all hitting one poor, overloaded server. The load balancer, the ELB, it stands in front and it distributes all the requests evenly across a fleet of servers.
But the real magic happens when you combine that with auto-scaling.
This is the holy grail. Imagine this scenario. It's 9 a.m., everyone logs in for work, traffic spikes. The auto-scaling group detects that the CPU usage on your servers is hitting 80%.
It's getting hot.
So automatically, without a human touching anything, it spins up 2 more servers. The load balancer sees them, registers them, and starts sending them traffic.
Yeah.
Performance stabilizes.
And then midnight comes, everyone goes to sleep.
Traffic drops off a cliff. The auto-scaling group sees that CPU usage is now down to 5%. It terminates the extra servers, and you stop paying for them.
That is the elastic in EC2 made real. But there is a yes, but here too, isn't there? The dreaded health check.
Oh, the health check death spiral, yes.
Tell me about the death spiral.
So the load balancer pings your servers every few seconds. Are you there? Are you healthy? If a server crashes, the load balancer stops sending you traffic. That's good, right?
Sounds good.
But if you configure the health check wrong, let's say you tell it to check a page that takes 10 seconds to load, but the timeout is set to only 5 seconds.
The load balancer thinks the server is dead.
It thinks it's dead because it didn't answer in time. So the load balancer kills the perfectly healthy server. Then the auto-scaling group sees a server died, so it starts a new one.
But the new one has the exact same bad configuration.
Exactly. So the load balancer asks the new server, are you healthy? It takes 10 seconds to answer. The load balancer kills it. And you end up in this loop where your own automation is murdering your own infrastructure over and over again.
Automation is a powerful servant, but a very dangerous master.
Precision is absolutely key.
Which leads us to the modern workflow. We aren't dragging and dropping files anymore. We aren't using FTP clients. We are using CI/CD.
Continuous integration and continuous deployment.
And this is the portfolio project that gets you hired, right?
It is. If you want to impress a recruiter in 2026, you don't send a PDF resume. You host a static website on S3.
But you don't just upload the HTML file manually.
No, that's amateur hour. You set up a pipeline. You put your code in a repository on GitHub. When you make a change, say you update your skills section, you just push that code to Git.
And then the magic happens.
GitHub Actions kicks in. It sees the change. It grabs the code. It maybe runs some automated tests to make sure you didn't break anything. And then it automatically pushes that update to your S3 bucket.
So the deployment is completely hands-free.
It removes human error. How many times has a website gone down because a developer uploaded the wrong file or forgot to upload a CSS sheet? CI/CD standardizes that entire process. A resume isn't a document anymore. It's a live, cloud-hosted, auto-updating web application.
That is a massive shift in mindset. It's not just about building the thing. It's about building the factory that builds the thing.
That is a beautiful way to put it. We are moving toward infrastructure as code.
Explain that phrase. Infrastructure as code.
It means you don't log into the AWS console and click buttons to build a server. You write a script using tools like Terraform or CloudFormation that describes the server. You write, I want 1 VPC, 2 subnets, and a T3.micro instance.
And then you just run the script.
And the cloud builds itself from that script. This means your entire infrastructure is version controlled. You can undo a change to your data center just like you undo a typo in a Word document.
That is the future. So looking at the big picture here, we have the layoffs, but we have this gold rush. We have this incredibly complex machinery of regions, IAM, EC2, VPCs. Where does this leave the listener?
It leaves them with a choice. The industry is facing that 60% skills gap. The hardware is gone. The people who used to rack servers are retiring or retraining. The need for architects is higher than it has ever been.
But it feels so daunting. 200 services.
But you don't need to memorize 200 services. You need to understand the Lego blocks we talked about today. Compute, storage, network, security. If you truly understand those 4 pillars, if you understand why latency matters, why security groups have memory, the rest is just detail. The specific button names might change, but the physics of it doesn't.
We are moving toward a world where you don't even touch the hardware. You're the conductor of an orchestra you can't even see.
Exactly. And that raises the final question for everyone listening. Are you still trying to maintain the hardware, metaphorically speaking? Are you still trying to do things manually, clicking buttons? Or are you ready to become the architect of the invisible? Because that's what cloud engineering is. It's building massive city-scale infrastructures that live entirely in code.
That is a wild thought, the architect of the invisible.
It's the future, and it's a very lucrative one.
Well, on that note, I think we're going to wrap up this deep dive. Whether you're looking to pivot your career, protect your startup from a $3,000 surprise bill, or just understand why your Netflix stream is so incredibly reliable, the cloud is the engine underneath it all.
Absolutely.
Keep building, keep scaling. We'll catch you in the next one.
Take care, everyone.